So looking at number 6, and again, this is the back of this sheet, the Honors Chemistry Molarity Dilution Practice. So number 6 says the lab materials require 150 milliliters of 0.75 molar sodium hydroxide solution. Let me ask you something. Sodium hydroxide, there's something special about that. What did you learn about sodium hydroxide? It's a strong base. The stock solution is 2 molar. Now, had the word stock been erased, how would you know that that was still the stock solution? It's a higher concentration. Describe how you would prepare this solution, including the calculation to determine the necessary amounts needed. Now, I told you when you did this, you did not have to do the describe part, but I still wanted you to do the math of it. So technically, we have the the MD and the VD there. They give you the MS here, so what are you missing? All right, so we're looking for VS, which is equal to MdVd all over MS. So it should have been 0.750 times 150.0 milliliters, all divided by 2.00. And what was your answer in the correct number of significant figures? 56.3 milliliters of NaOH. Does that make sense? If you want to put aqueous, that's fine. So, here's how, go ahead. So, how was, like that exact number? In liters? Why was it in liters? Does it make sense why it has to be in milliliters? Well, but what I'm saying is the unit of volume they give you in the problem is milliliters. So molar and molar cancel, leaving you with milliliters. Does that make sense? Okay. All right, now I want to just verbalize the explanation of this. So you would start out by measuring out how much sodium hydroxide. No. 56.3 milliliters of 2 molar sodium hydroxide. What would you pour the 56.3 milliliters into? Very good. 150 milliliter volumetric flask. Does that make sense? Then what would you do? Pour water in to do what? Fill it up to the line on the meniscus. And that would create a 0.75 molar sodium hydroxide solution. Sir? Only acid, yes, not bases. So this one you pour the base in and just pour water on top of it. Okay, sir? Gotcha. Okay. Very good. All right, so number 7. A chemist wants to try to dilute 50 milliliters of a 0.35 molar sulfuric acid to 2 molar sulfuric acid. To what volume must it be diluted? So that's an easy question, right? Very straightforward. What variable were you solving for? Okay, so VD is equal to MS VS over MD. Is that right? Yeah, that's right. That's right. That's correct. So the molarity of the stock is 3.50. The volume of the stock is 50.0 milliliters, all divided by the dilute molarity, which is 2.00. So what was your final answer to correct sig figs? 87.5 milliliters of H2SO4. Okay, go ahead. Sure, because technically it's diluted. Ma'am? It's still sulfuric acid. It's just more diluted. Ma'am? Yes. Okay. Now, this next one's a little tricky, but still same kind of concept. How many milliliters of stock 12.1 molar hydrochloric acid is needed to prepare 500 milliliters of a 0.1 molar hydrochloric acid? The reason this one was kind of weird and funky is because it tells you explicitly you need it in milliliters. So even if you wanted to, could you convert the 500 to liters? You could, but then you'd have to convert it back at the end, and that wouldn't make any sense, right? Just want to make sure I'm not going to work this because that's pretty straightforward. What's the answer you guys got? Correct sig figs. 4.1. Very good. Why 4.1? 0.01 is 2 sig figs. Fantastic. Okay. All right, number 9. Now, and I gave you a hint on this one. What was the hint that I told you to write down? Total. So this was going to take a little bit of thinking right here. It says, in an effort to conserve lab material, an assistant combines two was this the one that was the same? All right, so I'm not working it again. Oh, well then, spectacular. So let's just move on. Well, that's good. That means if you got it right, then check your packet. No, the packet, the notes that we did. I'm doing it Monday and Tuesday. All right, so this is the other one I want to work, and I don't know if you guys got to it, but I want to work the back of it. Okay. All right, we haven't done these, correct? Okay. All right. So number 4, it says describe how you would prepare 7 liters of a 0.75 molar. What is that solution? No. Potassium chromate. Okay. From a 2.25 molar potassium chromate stock solution. Let me ask you something. How would you know that second concentration is still the stock, even though it doesn't say it? Or even though if it didn't say it? The concentration is higher. Fantastic. So we need to do some... Say that again. Yeah, I like that. That you're diluting the next thing. I like how you said that. Yes. Okay. All right. So I know that I need to solve for my VS, which is MdVd over MS. So that tells me that I've got 0.750. You have or have not had a chance to do this? All right, well, that's fine. We'll work it out together. 7.00 liters, all divided by the stock concentration, which is 2.25. Now, so I am going to kind of need your help as far as working this out. So how many sig figs? Now, here's an important question. That's 10.3 what? Oh, 2.3. I thought you said 10.2. So it's 2.33 what? Liters. Very good. Of K2CrO4. So 2.33 liters of K2. So here's what I want you to do. I want you to write down the explanation. See if you can figure that part out. I think there was an explain. No, there was not an explain on the front. See if you can do it. Okay. This is not an acid, so you don't have to add water first. So it's pretty self-explanatory. All right. So I kind of like where she started with this. Again, if you want to say measure out in a graduated cylinder or beaker, that's perfectly acceptable. We're just going to shorthand this one. So we're going to pour 2.33 liters of K2CrO4 into a what? 7.00 liter ball. Sure. Okay. Sure, I would. Then, what would you do? What's up? Okay, this would make 7 liters of a 0.75 molar potassium chromate solution. Right, that would be your last sentence. All right, text the number.